Welcome everyone to the second part of the webinar series. Today we'll be reviewing about nitrate solutions which help in reducing hydrogen sulfide gas concentrations to safe levels and prevent corrosion. In this presentation, we'll be talking about what liquid phase technologies are, what are the major factors we take into picture when designing a solution for odor and corrosion control issues. Then we will move to the topic of interest, what nitrate chemistry is and what type of solutions are available. We will be discussing in detail about the prevention mechanism and the application guidelines for each solution. At the end of the presentation, we will be going through a case study we have performed in order to attain recommended odor and corrosion control treatment goals. Moving on to liquid phase odor control. When it comes to the treatment of hydrogen sulfide, we have two major ways of treatment in order to obtain complete odor and corrosion control of wastewater systems, namely liquid phase and odor phase, vapor phase. In liquid phase, we will be dosing solutions directly into the wastewater either to inhibit the formation of hydrogen sulfide or to retain the hydrogen sulfide in dissolved form. Like I just said, liquid phase technologies control the release of odor and corrosion-causing compounds from wastewater streams. Majorly, sulfide controlling applications fall into two categories. One is improving the oxygen balance of the wastewater system. This happens either by injecting air or oxygen into these units. Secondly is the chemical addition, where we try to add chemical oxidation solutions or sulfate reduction inhibitors or pH control solutions, etc. These technologies are commonly used in wastewater collection systems. These solutions retain the hydrogen gas molecules from escaping into vapor phase. We also help in controlling odors at manholes, air release valves, and repump stations also. Moving on to our nitrate solutions or the biochemical solutions, which promote the activity of bacteria, in our case, the thiobacillus denitrifying bacteria, to consume nitrates. They further help in oxidizing the reduced sulfur compounds by increasing the ORP of the wastewater. They're majorly available as the calcium nitrate or the ammonium nitrate solutions. Nitrate solutions biologically prevent the formation of hydrogen sulfide gas. The available formulations here are BIOXIDE, BIOXIDE AQ or anthraquinone, and the BIOXIDE plus 71 solutions. Bacteria in the presence of nitrate solutions will preferentially metabolize nitrates over the sulfates. Moving on to the prevention mechanism on how these nitrates act as alternative oxygen resources to the bacteria present in wastewater. So the bacteria takes up the nitrates present in wastewater. The bacteria consumes the oxygen molecules available in the nitrates, in the form of nitrates, and that oxygen actually combines with the organics that is present in the form of food or waste matter and forms carbon dioxide. The remaining nitrate or nitrogen molecules recombine back, forming nitrogen gas, and is expelled out as nitrogen gas from the bacteria walls. So the nitrate solutions have two main types of mechanisms based on the feed point conditions: prevention mechanism and the removal mechanism. The prevention mechanism in anoxic wastewaters, where oxygen is kind of in a very less state, the BIOXIDE solution prevents the formation of H2S itself by providing an alternative oxygen source. As you can see in the reaction, the carbon matter or the organic matter present in wastewater consumes the oxygen off of the nitrates, thus resulting in carbon dioxide and nitrogen gas. This reaction does not require any retention time as such, but it requires 2.1 gallons of chemical for every pound of hydrogen sulfide prevention. Moving on to the next mechanism, which is our removal mechanism. In case if there is any hydrogen sulfide already pre-existing at our application point, the microbiology will, with the help of the nitrate solutions, will naturally remove the hydrogen sulfide by restoring it back in its ionic state. As you can see in the reaction, the nitrates react with the hydrogen sulfide gas, resulting in sulfate ions, and nitrogen gas is expelled as usual. This reaction requires a minimum of 1.5 hours or 90 minutes for from contact time till the completion for the removal of hydrogen sulfide gas. This mechanism requires 0.7 gallons of nitrate solution for 1 pound of hydrogen sulfide removal. So moving on to our first and the major type of nitrate solutions available here with Evoqua are the BIOXIDE solutions. So the BIOXIDE solution is an aqueous calcium ammonium nitrate double salt. They are usually clear liquids and they're slightly colorless too, with a tan coloration in them. They're usually odorless liquids. It has a density of 11.5 to 12.3 pounds per gallon, with a freezing point of less than 10 degree Fahrenheit. It has a boiling point of 218 degree Fahrenheit to 221 degree Fahrenheit with a pH of 4 to 8. The active ingredient in the BIOXIDE solutions is the nitrate oxygen. Here we have 3.5 pounds of nitrate oxygen per gallon of BIOXIDE solution. Moving on to the application guidelines of BIOXIDE solutions. BIOXIDE solutions are best used at the pump stations or the collection points of these wastewater units, and also along the force main injection points. It requires a minimum of 1.5 hours of retention time for H2S removal, but in case of H2S prevention, there is no minimum retention time requirement. The BIOXIDE solution is best applicable where chemical safety is a major concern and where we are trying to reach really strict H2S treatment objectives. We practice really good care in feeding BIOXIDE into our wastewater streams to limit the nitrate entering the treatment plants, to prevent nitrogen gas-induced solid flotation, or in other words, matting on these low flow rate wet wells. We also avoid large nitrogen gas buildups in certain types of force mains. Good care is taken to address all these issues. The next solution we have here is the BIOXIDE plus 71 solution. It is a calcium nitrate tetrahydrate with sodium chloride. It appears to be slightly colored when compared to BIOXIDE, and it's a clear solution. It has a slight chlorine smell for the liquid, and the density is 10.8 to 12.5 pounds per gallon with a freezing point of less than 25 degree Fahrenheit. It has a pH of 8 to 10, and the active ingredients are nitrate oxygen, which is 2.4 to 2.9 pounds, and sodium chloride, which is 0.1 to 0.3 pounds per gallon of BIOXIDE plus 71. Moving on to the application guidelines. BIOXIDE plus 71 solution is best used similar to BIOXIDE, at pump stations and also along the force main injection points. The solution requires a retention time of 1.5 to 12 hours. It is best applicable again where some chemical safety is a major concern and where we are trying to reach really strict hydrogen sulfide goals. We practice again good care in feeding BIOXIDE plus 71 into our wastewater systems to avoid the possibility of wet well matting or fog accumulation, which is fats, oils, and grease, due to the breakdown of the nitrates. However, feeding BP71 has a lesser possibility of fog accumulation as compared to BIOXIDE due to its slightly lower nitrate concentration. The faster reaction rates than compared with the BIOXIDE helps in easier treatment of hydrogen sulfide in a shorter period of time. It also helps in oxidation of non-sulfide related odors, maybe due to the carbon matter inside the wastewater. So it helps us in removal of such odors as well. The mechanism of BP71 is very much similar to our regular BIOXIDE in terms of removal and prevention. In terms of removal, we are trying to provide with the biochemical oxidation of existing sulfides, we are restoring back the sulfides in its sulfate ionic form. In the prevention mechanism, we are trying to provide the microbiology with additional source of oxygen. The chloride component is also capable of directly oxidizing the existing sulfides in both ionic form and also dissolved gaseous form. So in terms of sulfide ions that are existing in wastewater, we try to restore it. The chloride component tries to restore it back as the sulfate ion component state. And the hydrogen sulfide gas molecules, which are in the dissolved format, are restored back as ionic sulfides. The chloride component also helps, like I mentioned, to oxidize all the organic matters that's present in wastewater, hence removing all the organic related odor issues as well. The next solution we have here is the BIOXIDE AQ. The BIOXIDE AQ is a calcium ammonium nitrate double salt with anthraquinone, where AQ stands for anthraquinone. Its appearance is a cloudy light brown color, and it's slightly odorless. Its density is 11.8 to 12.2 pounds per gallon. It has a freezing point of less than 5 degree Fahrenheit, with a boiling point of 218 degree Fahrenheit to 221 Fahrenheit. It has a pH of 4 to 8, and the active ingredients are nitrate oxygen and anthraquinone. Here, the nitrate oxygen is almost 3.5 pounds per every gallon of BIOXIDE AQ solution. Moving on to the mechanism for BIOXIDE AQ is very similar to that of the other nitrate solutions, the BIOXIDE solution as well, in terms of removal and prevention. In terms of removal mechanism, it is helping in removing the already pre-existing hydrogen sulfide gas molecules by biochemical oxidation of existing sulfides, and the prevention mechanism by providing an alternative oxygen source to the microbiology present in wastewater. The anthraquinone, also called aquat, that's present in the BIOXIDE AQ solutions, acts as a natural inhibitor to the respiratory process of these sulfate-reducing bacteria, which is resulting in lesser production of sulfides and, in turn, hydrogen sulfide gas. The BIOXIDE AQ solution is ideally suited for the following hydrogen collection systems, where the retention times are pretty long. So compared to BP71 or BIOXIDE, we can use it for long retention time field locations. The treatment goals are very strict, and where chemical safety is a major concern. The good takeaway from this, the application guidelines for all three solutions are, like all the nitrate solutions here, have really good treatment, are able to reach really good treatment goals, and also are best applicable where chemical safety is a major concern. Moving on to the case study. We have performed recently a case study at a location in the north. We were contacted to provide an odor control solution at a pump station closer to a residential area or an elementary school. Here, the customer requires an application of a non-hazardous solution with extremely low H2S treatment goals. This location has a pump station that's having a force main that is breaking into gravity right at the playground of this elementary school location. It had a history of high levels of corrosion, which led to a gravity line collapse on the school grounds itself. The customer also requested for a chemical dose demand with a clear hourly chemical dose required to prevent the 100% formation of hydrogen sulfide gas, and also preventing the over and underfeed of chemical treatment. Having said that, we also did some distinctive study to collect a lot of preliminary data at that particular location. So as you can see, the feed point leads as a force main to the outfall manhole, and from there it's breaking into gravity to the downstream lift station. So we have collected some H2S data at that outfall, see how much of H2S is residing in that manhole, and we have noticed an average of 152 ppm per in the period of 3 to 4 days. This feed point is noticing a wastewater flow rate of almost 1.3 million gallons per day. It has the force main length of 13,000 feet approximately, with a force main diameter of 30 inches. The temperature at this location is 68 degree Fahrenheit with a BOD of 250 milligram per liter. Having all this force main information, we try to calculate the average retention time of the wastewater as 8.4 hours. Moving on to the solutions, or what type of solution we have chosen. The customer wanted a more biological solution. So having that in mind, and also taking the residential surroundings and the elementary school into consideration, we have understood that nitrate solutions would be the best application for odor and corrosion control. In the nitrogen solutions that are available to us, we have chosen BIOXIDE solution with the advanced dosing controller for the following reasons. 1, safe application. 2, we are able to prevent 100% hydrogen sulfide formation with the help of BIOXIDE solution. And 3, preventing the over and underdose of these solutions with the help of our advanced dosing controllers. With a lot of constant liquid sampling, we were able to get a good amount of dissolved sulfide and the pH value data, and we were able to calculate the rate of sulfide generation, which is approximately around 10.85 pounds per gallon per hour. So having that in our mind, and with the amount of wastewater flow rate changes throughout the day, we were able to match that with the amount of bioxide that's required to be fed at that location. We have also considered the amount of optimal with over and under dose possible at that location. With all the information that's available to us, we were able to calculate the estimated dosage of bioxide as 248 gallons per day. The results at this location after we started feeding and versus the comparison with the before one is before we started treating bioxide at that location, the untreated hydrogen sulfide data at the outfall manhole turned out to have an average of 152 ppm with a minimum of 7 ppm and a maximum of 645 ppm. When we started treating bioxide solution at a 248 gallons per day rate, we were able to bring down the average to 1.2 ppm with a minimum of 0 ppm and a maximum of 19 ppm. This clearly indicates the effectiveness of bioxide solutions in completely bringing down the hydrogen sulfide levels almost close to zero, eventually reducing odor and corrosion issues. The next presentation will be about pH shift technologies by Madeline Murphy, who is our application engineer here at Municipal Services. She will be talking more in detail about what type of alcogen solutions are available with us here that help in hydrogen sulfide mitigations. If you have any questions, feel free to contact us. Thank you so much for all your attention and time.
Thank you, Dee. We've had a few questions roll in, and if anybody else would like to ask a question, you'll notice the question icon in your GoToWebinar dashboard. You can submit your questions there, and we will roll through what we have right now. The first question, and I think you may have just answered it with the indication of the following webinar with methylene. Do you have any nitrate-free solutions for odor control? Some regions are seeing very strict nitrogen levels being enforced, and nitrate-based products may be causing excessive nitrates at the effluent of plants. Do you want to take that one, Dee?
Yeah, sure. So like you just said, we are coming up with more technologies in the future webinars where you'll try to understand that nitrate solutions is not the only option for treatment, but we can tailor our application to the requirements of the customer itself. So if there are limitations of the use of nitrates, we are having better technologies in terms of pH shift or even ion salts. So depending upon what type of conditions we are working with, we have alternative solutions as well.
Great, thank you. We have a couple of questions about cost of treatment and the cost split between the three different BIOXIDE products that you mentioned, Dee. And that's a tough question to answer. The true answer is it really depends on what your treatment goals are, what the objectives are, you know, proximity to terminals, whether or not you want any type of ongoing service or monitoring. So typically we sell service packages as opposed to quoting a price per gallon of a particular product, and of course, depending on terminal locations and where we're delivering the product to, there are freight costs that vary from site to site and customer to customer. We have another question. When you add BIOXIDE, which mechanism is dominant, prevention or removal? Do you want that one, Dee, or do you want me to take it?
Oh, I can take it, and maybe you can a little more expand on it. We usually target for the prevention mechanism, and it majorly depends on the preliminary data that's available at that site on how much of sulfides are existing at that particular feed location, and also how much my atmospheric hydrogen sulfide levels are looking like. So based on that specific location, we try to dose accordingly based off of that. So we definitely target for the prevention mechanism in the first place, but if there is high amount of hydrogen sulfide that's already pre-existing in dissolved format, we target for the removal as well.
Great, wonderful answer, Dee. The next question, what is the advantage of having the ammonium calcium nitrate double salt? So the advantage, and I should state that Evoqua has both a calcium nitrate solution and a calcium ammonium nitrate double salt solution. The benefit of the double salt solution is that it has a lower freezing temperature. So if you imagine, you know, our friends in the north, we're here in Florida, we don't have to deal with it, but our friends in the north, when it gets cold, it's not a good thing to have the tanks freezing or product salting out. So we would advocate the use of the double salt solution in those areas. Do recognize that ammonia discharge limits are increasing, and that's an ever increasing concern. So we do have the option of heat tracing tanks and stuff like that if the use of the double salt solution is not going to work for a particular site or customer. See, reading through the questions, more about the cost. The cost difference between BIOXIDE plus 71 and BIOXIDE AQ, just in very general terms. BIOXIDE is a basic product, and the other two products have some manufacturing and additives that go into them. So you would expect BIOXIDE AQ and BIOXIDE plus 71 to be more expensive than just basic BIOXIDE, but they also offer additional benefits and treatment. So there, you know, there's a cost difference, but then you also have to weigh the added benefit of the different solutions. When is BIOXIDE plus 71 or BIOXIDE AQ used instead of BIOXIDE? Do you want to field that one, or would you like me to take it?
Oh, yeah, I can take that. So first part of the question, where we use BIOXIDE plus 71 or BIOXIDE AQ. Usually BIOXIDE plus 71, we take it up for low retention time wet well locations or force main locations. So like I mentioned, we have just a retention time limitation for 8 to 12 hours. If that was the case, we go with that. And also if it's a low turnover wet well, we usually go with that case if they want to see lesser wet well matting. But if we are looking for a longer retention time locations, we usually go with the BIOXIDE AQ or the BIOXIDE solutions particularly. So again, it mostly depends on the amount of force main information or the force main scenario we are dealing with at that location.
Great, wonderful, Dee. We have a question about dosing. What additional information can you provide regarding advanced dosing control systems? How is dosing controlled? Is it predictive? And I'm happy to take this one. So we at Evoqua have a variety of different methods for dosing chemicals into a wastewater collection system for odor control. When we talk about advanced dosing controllers, we're specifically referring to devices that have remote telemetry and are able to be operated remotely. So in practice, what that would look like is one of our trained service technicians would log into our web portal and have the opportunity to manipulate dose rates remotely. How is dosing controlled? Well, there are two primary methods that we use. The first is flow pacing or ppm dosing, wherein we would establish a ppm dose set point for every hour of the week, and using a wastewater flow signal, we would change the metering rate of the odor control chemical to maintain that ppm dose set point in the wastewater. And the other method would be to use a pre-programmed curve wherein we're varying the dose rate 168 points over the course of the week, or one dose rate for every hour of the day, interpolating between dose points to match the dose to the demand for odor control. The question goes on to ask, is it predictive? There is not a lot of need. So wastewater collection systems tend to be pretty static day over day, right? And what I mean by that is we don't see a lot of change day over day in the way the wastewater is moving. Now, of course, there are certain events that'll happen. Super Bowl halftime, for example, you would expect to see a lot more water flowing through the collection system, but by and large, we don't see a lot of change day over day in the way the wastewater moves through the sewer. So there's not a lot of need to be exceedingly dynamic. Now, predictive dosing does present an opportunity for further refinement, and that's something that the industry will be exploring in the future. And that is the last question and also the end of our time together. So thank you everybody for attending. We appreciate the engagement and hope to see you all in the next webinar.